We are looking at this question related to a continuous random variable, where in the first part we found the unknown constant k in its PDF using the fact that the PDF integrates to 1, and we found that k was 1 by 4, right? So this is already done. So now we want to find the probability that this continuous random variable is less than 0.3 and is greater than 1. Before we do that, there's something that we want to recall. So recall for a continuous random variable, so CRV is continuous random variable, area under PDF gives probability, right? So this is the keyword, this is the key thing here, area under PDF gives probability, right? Basically, and we know we can find the area under the curve using integration. So to find the probability, that the continuous variable lies, CRV is again continuous random variable, lies in an interval, integrate the PDF over that interval. So this is the key concept to remember here. Integrate the PDF over that interval. So what we're saying is for any continuous random variable, area under the PDF gives probability, and you can find the area under the curve using integration. So if you want to find the probability that the continuous random variable lies in an interval, integrate the PDF over that interval. So in the part B, we wanted to find the probability that x is less than 0.3. Essentially, the idea is that you want to integrate the PDF over this interval. How we can be more specific about what this interval is? How can we do that? We know the PDF for the continuous random variable is given by this. And this is told to us is given by this when x is between 0 and 2, right? So the PDF is only non-zero, right? The PDF is only non-zero for values of x between 0 and 2, and a continuous random variable only takes those values where its PDF is non-zero. So in this case, a continuous random variable only takes values where its PDF is non-zero. So what I can do is if I want to find, we have to integrate the PDF for this interval, but you can be more specific about what the interval is by taking into account what values the continuous random variable takes. I can write this as probability x is greater than 0, less than 0.3. So we can be more specific about an interval given to us by taking into account the values the continuous random variable takes, right? Where does the 0 come from? It comes because x takes on values between 0 and 2 where its PDF is non-zero, because the continuous random variable takes those values where its PDF is non-zero. This continuous random variable takes on values between 0 and 2. So it's always note. So the idea is that always note what values does the random variable take on, right? Because then you can be more specific about what this interval is. So we can write the interval probability x is less than 0.2 as the probability x is between 0 and 0, sorry, probability x is less than 0.3 as the probability x is between 0 and 0.3, because the continuous random variable only takes values between 0 and 2 where its PDF is non-zero. So now we know to find the probability lies in any interval, you can just integrate the PDF over that interval. So we'll just integrate its PDF where we found k to be 1 by 4. We'll just write it outside. 1 by 4, 6x minus 3x, right? So to find the probability it lies between 0 and 0.3, we can just integrate the PDF from 0 to 0.3. And once we integrate this, so this would be 6x squared by 2 minus 3x cubed by 3, 0 to 0.3. And then when we just plug in the limits in this, so this would just be 0.3 square minus 0.3 cube. And this just turns out to be 0.06075. So in this way, we can find the probability that x is less than 0.3. So just keep in mind, whenever you're answering any probability question of a continuous random variable using its PDF, always see if you can make the interval more specific, right? Like in this case, probability x is less than 0.3 can be written as probability x is between 0 and 0.3, right? So always see if you can make the interval more specific by taking into account what values the random variable takes on. And a continuous random variable takes on values where its PDF is non-zero, which in this case is between 0 and 2. This is where this 0 came from, right? So the next part is probability x is greater than 1.2. Again, what we'll do is we'll make it more specific than interval. by taking into consideration that x only takes values between 0 and 2, where its PDF is non-zero, right? So let's just raise this up. Okay. Okay, so integrate. Yeah. So part C is prob sorry. Part C is the probability x is greater than 1.2. Again, we can write this as the probability that x is greater than 1.2 and less than 2. Where does this 2 come from? This 2 comes from the fact that x takes on values between 0 and 2, where its PDF is non-zero, right? So this is where this 2 comes from, right? So basically, we know okay, x takes on values between 0 and 2, its PDF is non-zero. So this means that the probability x is less than 1 by 2 is essentially the probability that x is between 1.2 and 2, right? That's what it means. So again, we want to find any probability related to a continuous random variable using its PDF. We just integrate the PDF over that interval. So we integrate the PDF from 1.2 to 2. So we have 1 by 4 here, and then we have 6x. The 1 by 4 is the value of k that we found. 6x minus 3x squared dx. Again, you just have to integrate this. So this is just going to be 6x squared by 2 minus 3x cubed by 3. Then it's 1.2 by 2. And then we just simplify this. So this just becomes 3. Sorry, okay, so then you can just simplify this. So it's 3x squared minus x cubed to 1.2. Now just plug in the limits in this and we will see now this turns out to be 0.352 if we just plug in first to the limit 2 in it and then subtract from what we get and subtract from this what we get when we plug in the limit 1.2. Right, so the idea also like we said this we can write so vision probability this. So we said taking into account the values it takes, we can write probability x is greater than 1.2 as probability x is greater than 1.2 less than 2, right? So this is where does this 2 come from? It comes from the fact that the continuous random variable takes on values between 0 and 2, where its PDF is non-zero.